So this is 7.4b in college trig, vectors, operations, and the dot product, and we're in example 1. It says find the magnitude and direction angle for u equals 3, -2. Okay, what do I know? I know that I go over 1, 2, 3, and down 2. So I've got a point right there, and my magnitude is there, and my direction angle will be whatever angle that is right there. But I know I'm in the fourth quadrant. So to find magnitude is square root of a squared plus b squared. Okay, so my a is going to be my x value, and we said that that was 3 plus -2 quantity squared. So that's 9 plus 4, that's going to be the square root of 13. So that's what my magnitude is, the square root of 13. Not too bad. To find the direction angle, when they give me this will always be my opposite and my adjacent. So I know I'm going to be using tangent. So tangent of theta is going to be b over a, which in this case is going to be -2 over 3. So the tangent of -1, so the arctan of -2/3 is going to give me -33.7. So that's this point right there. So I'm going to have to take 360 minus 33.7 in order to get this angle right there, and in this case it'll be 326.3 degrees. So my magnitude is going to be the square root of 13, and my direction angle is going to be 326.3. Okay, so let's continue on. Horizontal and vertical components. So what we just did with magnitude and direction angle is I was able to find the strength of the vector, and I was also able to find the direction angle. Well, sometimes you're given the magnitude and the direction angle, and they're interested in finding these two, and those are called the horizontal and vertical components. So if you're looking for A is going to equal the absolute value of u, and in this case it will be w, cosine of theta, and B is going to be, again, the absolute value of u, sine of theta. So this is the x value, and this is the y value, if you're given the, let's say, the magnitude and the direction angle. So let's look at example number 2, where they give us that, and they're telling us that my angle is 41.7 degrees, and they're also telling me that my magnitude is 25. So let's put a 25 there. So let's find A and B. So A is going to be the absolute value of 25, which obviously is 25, times the cosine of 41.7. And B is going to be the same thing, but it's going to be the sine of 41.7. Multiply those out, you get A is 18.7, similar to, and B is similar to 16.6. Okay, so then we would write W, which is the vector we were doing up here, equals, if I want to name it, I mean it's obviously called W, but I can label it according to the components, like that. Okay, so don't forget those little squared off or pointy things there. And that's it for finding that. Alright, so we're going to jump up to example 3. So what they're giving me is a couple different vectors. They're giving me the blue one U, the red one V, and the green one W. And what they're asking me to do is write each of the vectors in the form A, B. So I need to find the X, Y. Alright, so let's look at U. U is going to be 5 cosine of 60, that's my X value, and 5 sine of 60, that's my Y value. Okay? So, gosh, cosine of 60 is a half, so this is going to be 5 halves. And sine of 60 is square root of 3 over 2, so this is going to be 5 square root of 3 over 2. Okay? You're going to do the same thing with the V, only you're going to use the number 2 here because that's how long it is. And then you're going to use, your cosine and sine, but in this case it's 180. And then the last one, W, the length is 6, so it's going to be 6 cosine of 280 and 6 sine of 280. And then when you're talking 280 degrees, it's not one of those easy angles. You're just going to find the sine of 280 and the cosine. You're going to end up with a decimal. Okay, so middle of page 308. The following properties of parallelograms are helpful when studying vectors. A parallelogram is a quadrilateral whose opposite sides are parallel. Remember that. The opposite sides and opposite angles of a parallelogram are equal, and adjacent angles of a parallelogram are supplementary. So, again, if we've got a parallelogram here, this angle and this angle is going to add up to 180. This angle and this angle are going to be the same as this and this are going to be the same. And 3, the diagonals of a parallelogram bisect each other. They cut each other exactly in half, but do not necessarily bisect the angles of the parallelogram. Those aren't necessarily going to be, this angle is not necessarily going to be the same as that angle. In a rhombus, that's true, but not in this. Okay, so that gets us to the end of this video, and we'll start with example 4 in the next one.